Hello, welcome back to Lulumath. This video is on solving systems of equations by elimination. This is part two of two videos. So if you didn't get a chance to check out part one, make sure you do so before you watch this because it has some information to help you out leading into this video. So our first example that we have here has a system of equations that needs to be solved by elimination. So our first equation is 4x plus 3y equals -1, and our second equation is 5x plus 4y equals 1. And if you remember in part one, we had variables that easily eliminated because they were opposites of each other. So the coefficients were opposite values of each other. They would add together to give us 0. For example, we could add 5 plus -5 and we would get 0. They would go away. But if you take a look at what we have here, if I were to add 4x and 5x together, that doesn't cancel each other out. That gives me 9x. And if I subtract them, it doesn't cancel either. If I were to add or subtract 3y and 4y, neither of those would cancel as well. So what I'm going to do is try to rewrite my equations so they look different, but they're still equivalent equations. So that way I can get to a point where I have some coefficients that variables that are positive and negative values of each other that will cancel each other out. So let's take a look at our purple equation right here. Our purple equation is 4x plus 3y equals -1. And our blue equation, I'm going to write down as 5x plus 4y equals 1. And essentially what I'm going to do is I'm going to try to find, I'm going to pick a variable, and for that variable, I'm going to find the least common multiple. And that way I can multiply the equations by a certain constant to get the variables to be at a point where we can eliminate them. So I'm just going to randomly choose some variable to eliminate. So I'm going to eliminate the y's, okay? So I need to find the LCM of 3 and 4, okay? So remember, the least common multiple means values that are multiples of 3 and 4, but that have a common value. So an example right here, some multiples of 3 would be like 3, 6, 9, 12, 15, etc. And then multiples of, so this is for 3, multiples of 4 would be 4, 8, 12, 16, 20, so on and so forth. So if you notice right here, our value of 12 is in common with both of them. So that's the smallest common multiple. So I'll move this over here so it's not in my way right here. So since the multiple that I'm going to change them both into is a 12, I'm going to take my first equation right here and I'm going to multiply it by whatever value I'm missing in order to get to 12. So right here, I want to multiply this 3 by 4 to get to 12. But whatever I do to the 3y right here, I have to do to every single part of my equation, so I'm not changing it. I'm just writing an equivalent equation. So 4 times 4x is 16x. 4 times 3y is 12y. And 4 times -1 is -4. Okay? So I just would like to demonstrate to you that we didn't change the equation at all by multiplying by 4. We just simply wrote an equivalent version of the equation. So our original equation was 4x plus 3y equals -1. Okay, so that's this red line that we see here. Now I'm going to write the equation that we had after we multiplied everything through by 4. So 16x plus 12y equals -4. And if you notice here, it's the exact same line. So I'll turn off the blue line. It's now the red line. So we can see that the top equation is in red. When I turn the blue line back on, right here, you can see that it's on top of the red line because they are literally the exact same line. Now I want to take my blue equation and multiply it by a value that will bring me to 12 as well. So 4 times 3 is 12. However, I don't want a positive 12y because I want them to cancel out with this 12y right here. So I'm going to multiply by negative 3 so I can get a negative 12y. Okay, so let's go ahead and multiply through. So negative 3 times 5x is negative 15x. Okay, negative 3 times 4y is negative 12y, and then negative 3 times 1 is negative 3. Okay, so now I can go ahead and add these two equations together. So when I add 16x and negative 15x, I end up getting negative, or just 1x, or I can just simply write x down. 12y and negative 12y will cancel each other out, and negative 4 minus 3 is negative 7. So now I know what x is. I can use that information to figure out what y is now. So I'm going to take either equation that was given to me originally, and I'm going to replace the x with negative 7. So I'm going to start with, I'm going to use the purple equation. So 4x plus 3y equals negative 1. And instead of x, I'm going to replace that x with negative 7. So it's 4 times negative 7. And then I'm just going to copy the rest of this down, plus 3y equals negative 1. So 4 times negative 7 right here gives me negative 28. So I get negative 28 plus 3y equals negative 1. Add the 28 to both sides, and I end up getting 3y equals 27. Divide by 3, and I end up getting my answer for y, which is y equals 9. So therefore, my solution, my final answer, is going to be x equals negative 7, y equals 9, and I'm all set with this problem. Now, if you take a look at the next question, it says to solve the following system by elimination again. So we have this negative 3y plus 4x equals 12, and we also have this x plus 2y equals 14. But if you notice right here, the y here in this equation does not match up with the y in the other equation. They don't line up with each other, and the x's don't line up with each other either. So what I want to do instead is rewrite my top equation so that the x's and the y's line up in my system right here. So here, instead of negative 3y first, I'm going to write 4x first, and then I'm going to write the minus 3y, or the negative 3y, and then equals 12. And then I can just copy down this x plus 2y equals 14 right here, okay? So since I decided to eliminate the y's in the last question, I'm going to eliminate the x's in this question. So here my coefficients are 4, and then my other coefficient here is a 1. Okay, you don't see it, but it has an invisible 1 right here. So I want to find out what the LCD of 4 and 1 is. Well, this is nice because 1, any integer is a multiple of 1. So all I have to do is just change this 1 right here into a 4. So that means that my top equation, so actually let's write this down. So our least common multiple of 4 and 1 is equal to 4. So I don't have to change the top equation at all. I'm just going to rewrite it. So 4x minus 3y equals 12. I'm just going to copy that down. Now for the bottom equation, because I want this coefficient of 1 here to be a coefficient of 4, I'm going to multiply everything by 4. However, I want the 4x here to cancel out with this 4x. So since this is positive, I'm going to make this one negative. So negative 4x, okay? Times 1, negative 4 times 1x is negative 4x. Negative 4 times 2y is negative 8y. And then negative 4 times 14 is equal to negative 56, okay? So I can go ahead and add my two equations together. So 4x and negative 4x cancel each other out. I get 0. Negative 3y and negative 8y, when I put them together, is negative 11y. And then 12 minus 56 here is equal to negative 44. Divide both sides by negative 11, and I end up getting y equals 4. Well, now that I know what y is, all I have to do is figure out what x is. So I'm going to take my top equation, my bottom equation, which is x plus 2y equals 18. You can choose either equation you'd like. I'm choosing the second one because I chose the first one last time. And then every time I see a y, I'm just going to replace it with 4. So 2 times 4 is going to go here. I get x plus 2 times 4 equals 14. Now, all I have to do is just simply solve for x. Well, I know 2 times 4 is 8, so I get x plus 8 equals 14. Subtract the 8 from both sides, and I end up getting x equals 6. So therefore, my solution to this system right here is going to be x equals 6 and y equals 4. Okay? Thank you for watching this video. If you have any questions, please let me know in the comments or at lulumath.com. Just a reminder that there are blank note sheets as well as filled in note sheets available on lulumath.com, so you can find the sheets that go along with this video. As always, please make sure to subscribe and share this video with others. I hope you have a great day, and I'll see you next time. Thank you.